Morning guys, this is Steve Pugh, the City and Guilds course. It's video number 58. We're talking about energy efficient building. First thing to know about is the Energy Saving Trust. This is a social enterprise with a charitable foundation that offers impartial advice to communities and households and builders on how to reduce carbon emissions, and also to use water more sustainably and save money eventually on the energy bills. So they endorse certain products and they endorse certain methods of building, and they also have a verification system. Now, the great thing that we need to understand about is energy loss from buildings, and you can see that energy is lost all around this building. It's lost through the roof. About 26% goes through the roof, generally speaking. About 33% goes through the walls, but also you get it through windows, 18%, and through even the floor loses about 8%. Even doors lose about 3%. So you can see that it's not a great deal through doors. They tend to be fairly good insulation, but even drafts can be as much as 12%. Okay. So the next thing to know about is this concept of heat flow. Now, heat flow is what happens in a building between room to room, and also from the inside to the outside. So if you've got, say, 6 degrees on the outside and you've got various other temperatures in various rooms, you'll notice that the warmest room, which may be, say, 23%, will lose heat to a room that's just a few degrees lower. Okay, and normally speaking, on the inside of a house we don't have insulation between the rooms. Okay, but this is one of the things that we need to know about. You might have a scullery that has quite a low temperature, and that will suck heat from the next room, which may be of a higher temperature. Okay, so heat flow is something that's to be borne in mind with all of these things. The building regulations are very hot on this subject of heat insulation, and Part L, which is one of the parts of the building regulations, there's a number of parts to it. There's ADL 1A, ADL 1B. Now, the ADL 1A and B are referring to new dwellings. ADL 1A is new dwellings, and the second one, ADL 1B, is referring to existing buildings. But in existing buildings, there may be an extension, there may be some renovations, they might just have a change of use or even a change of energy status. So these regulations cover all of that. And then there's a second part to it, which is ADL 2A and ADL 2B. So this is new domestic buildings. These are ordinary houses where people live. The other are referring to just new builds. And the second part of it is existing non-domestic buildings, extensions, renovations, and change of use. This is an exceptionally interesting area of energy preservation. Okay, and it's very, very complex. The next thing we need to know about is that there is what's called thermal transference, and every item in a building will have a different U value. Now, a U value is based upon how many watts, that's heat, how many watts is transferred per square meter. Okay, and you'll notice here that there's single glazed windows a 4.5, double glazed windows a 3.3. Okay. Double glazed windows with advanced coatings and frames is 1.2. So the amount of heat that's transferred from various items in the building varies and goes up and down, and we can have a big long list of all the different U values. I will give you a few. A solid wall has a U value, that is a 9-inch brick wall, has a U value of 2.3. A cavity wall has a U value of 1.6. So that's nearly half of the heat is saved in a cavity wall, because the heat can't jump over that gap. That gap produces a cushioning effect to heat transfer. Now, if that cavity is filled with insulation of say 50 millimeters thick, and it has a lightweight concrete blocks on the one side and lightweight plaster, then it brings the U value right the way down to 0.48. Okay. Now we could go through all of the different types of U values, which is rather laborious, but suffice to say that there are quite a lot of variation in U value. Okay. Now the next thing to think about is what's called insulation materials, and we've got a whole raft of them. The first one's called blue jean or lamb's wool. It looks like just fluffy leftovers of the woolen industry. Sometimes when you're opening a roll of lamb's wool, you might even have a jumper in there. You might even have a pair of woolly socks because it's exceptionally good quality insulation. It's natural insulation. And it's very cheap to purchase. The next one then is fiberglass mineral wool. Now glass itself is not necessarily a great insulator. We know that from single pane windows. However, when it's spun into a fiber, the little pockets of air in between every filament is air that's still, it's not moving, and therefore it becomes a very good quality insulating material. It's what's used in lofts traditionally. The next one is PIR, which is polyisocyronate, which is the solid insulation that we're all familiar with that goes inside cavity walls, but it can be used in other settings as well. You can have it on the inside of a wall. It can even be purchased attached to plasterboard. Now, one of the less known means of insulation is called multifoil, and this is just a very thin foil of a plastic material that's a reflective material. We've all seen the reflective coats that you can put on you in a survival situation to keep body heat in. Well, the same can be used in buildings, but instead of just using a single sheet, they put many sheets. Every single sheet does a little bit of heat insulation. And when you've got 100 sheets, it becomes an exceptionally effective barrier. What's good about it is that it's very good at preventing moisture traveling through a building structure. Then, of course, we've got double glazing, we've got draft proofing methods. There's such a thing as a sealed house in which there's no air that passes from the inside to the outside. And there's special methods to obtain information about how much draft there might be. And then we have loose fill materials. Now these generally are tiny little polystyrene balls or something of that nature, or even like a dust, and it's injected into the cavity and it fills up the cavity on a loose fill. And that is an exceptionally effective insulating material. But then we have expanded polystyrene balls. We all know what polystyrene is. It's what you get in a box when something's delivered, normally to the shape of the item that you're having delivered, like a printer. But you can buy that also in large sheets, and they can be attached on the inside of a building, generally speaking, but they can also be put on the outside of a building and covered with render. It's a slightly different form of polystyrene, but it's the same overall thing. Then we have aerated concrete blocks. Now, autoclaved aerated concrete blocks are just a concrete block for building. However, they look like the inside, when you cut into it, they look like the inside of an aerobar. It's full of holes, and every hole has got a little bit of air in it, and that air is encapsulated, and so it acts as an insulating material. We have other ways of insulating. One of them is called expanded foam. This is where foam is sprayed on the inside of a roof or the inside of a loft or the inside of timber framing, and then it's cleaned off and plasterboarded, and that's an exceptionally good. What's good about that one is that it's very good at sealing for drafts. And then, of course, we all know about double glazing and triple glazing. These are just some things that's very commonly known. Okay, the next thing is energy performance certificates. Now, the thing about an energy performance certificate is that they're pretty well universal. You can get one on your fridge. When your fridge is delivered, it'll have a sticker on the outside with a number of bars, coloured bars, starting with A at the top, which is dark green, then B, C, D, E, and F, and G. And of course, depending on how high you go up the grid is how good that fridge will be at insulating the contents inside. And not only do we have them on fridges, but you can have an energy efficient performance certificate for a whole building. And this is where they take all the U values of all the building, and including all the insulation materials, and they'll give an energy performance certificate for the whole building. And there was a great boom in the use of these certificates a few years ago, but that seems to have died away. It was quite expensive to administer it, but the principles still remain the same. The next one then is sustainable materials. What we don't want to be doing is just cutting down trees, logging trees, or using up materials in such a way that those things are then permanently depleted from the planet. And so there's what's called managed timber sources, and the FSC are an international non-profit organization dedicated to promoting responsible forestry. So what they ensure is that yes, trees can be cut down as long as on a long-term plan other trees are being planted in their place. And in fact, the idea really is that more trees are planted than what are cut down, and that has the effect of reforesting the planet. Very important thing indeed. There's also a small thing called the Code for Sustainable Homes. This is a national standard for the sustainable design and construction of new homes, and it aims to reduce carbon emissions and promote a higher standard of sustainable design. So the current code provides 9 measures for sustainable design. First of all, it's to do with energy and CO2 production. Next one is the sustainability of water resources, of materials, of surface water, that is the runoff from flooding or rain, of flood prevention. There's also the sustainability of waste management and pollution and health and well-being, and the management of the ecology. So these are all important features in sustainability, and there is a sort of a 1 to 6 star system so that you can rate the overall sustainability of products and services. The next major thing is recycling materials. Now, it costs a tremendous amount of energy just to make one brick. Okay, imagine if you can reuse old bricks and do it in such a way that you haven't got to just smash them up and bury them in the ground, but you can reuse them and build buildings with them. Well, that's all about sustainability. That's all about recycling, and it's a very important feature of sustainability. I'll give you a few examples of this. You can have crushed concrete or brick and reuse it for hardcore. Bricks not so much. The building surveyors are not too hot about bricks because they do tend to crumble in the future, and we don't want to create a void underneath the concrete slab. And the reuse of tiles and slates, bricks cleaned up and reused for non-structural bearing walls, steel sections shot blasted and refabricated. Crushed glass is recycled as sand or as cement replacement, or for the manufacture of kitchen worktops. This is a big industry. The reuse of doors is a very important one. Generally speaking, most doors work fine in their original setting, and if they're a good door and they can be then reused or repaired, that saves a tremendous amount of effect on the environment. We have panel products, chipped recycled timber. We have reused timber sections and floorboarding, and the reuse of period architectural features. And lastly, the reuse of period fixtures and ironmongery. It takes a tremendous amount of energy to create ironmongery, like door handles and locks. And so by reusing some of that material, a tremendous amount of energy is saved. Well, there we are. That's our lesson for today. We look forward to catching up with you on our next episode. Have a great day. Bye for now.